This is Automagic Tuning. I'm Joey D'Antoni. You're at SQL Bits 2022 if you're in the room or if you're online. And we're going to talk about a really cool feature that was introduced in SQL Server 2017. And I just realized I'm going to have to do some desktop shuffling to go between slides and demo, so you get to watch me futz around on my Mac. But anyway, I'm Joey D'Antoni, Principal Consultant, Denny Cherry and Associates Consulting. I've been working with SQL Server and other databases and doing various stuff for over 20 years. I've been working with SQL Server since version 7. I'm a Microsoft Data Platform MVP. You can find me on Twitter at jdanton. I also blog at joeydantoni.com, and I write a monthly column called Joey on SQL for Redmond Magazine. If you have feedback for this session, which I hope you do, you can do it at this QR code and this URL, which also works as well. Either way you want to get there, and I'll pause for 10 seconds while you get that. So let's talk about the problem we have. You're on call. It's 2 a.m. You got paged. And the reason why you got paged is somebody saying, my query is suddenly slow. The lights are, everything's on fire. This is a real story that happened to me. I was teaching a class in Vancouver, Canada, which is about 3 hours behind where I normally live. And I happened to be on a call on the East Coast, so I was up at 6 a.m. And while I was on that call, another client called me and said, hey, all of a sudden, our queries are running slow, and our machine's using 90% CPU. Can you log in and tell me what's going wrong? Fortunately, with that customer, they had a very small query workload, and I was kind of quickly able to identify what was going on. Unfortunately, that solution doesn't scale. You can't put out water. You can't put out oil fires with water. They just get bigger. So you need a better tool. The solution, and yes, I know that's water. You need something a little bit more proactive. So starting with SQL Server 2016 and also Azure SQL Database and Azure SQL Managed Instance, SQL Server introduced a feature called Automatic Tuning. And what Automatic Tuning does, it continually monitors and analyzes the query workloads that are in your server. It's built on top of the query store, so it takes the metadata and runtime information that SQL Server stores in the query store, and in the event of a plan regression, it will apply the last known good plan, which is what I did with that customer at 6 a.m. I went into the query store, I found a plan that looked better than the one they had, or it looked like it was running more efficiently, and I went ahead and forced it. So this is how this works. The database engine continuously collects query plan performance information. So the way the query store works is every time a new query is executed, it generates a hash, and it also collects runtime information for every time that query is run. If the query regresses by more than 25% in CPU seconds over the course of 15 executions, which I think could be a little tighter, but I didn't write the feature, the database engine will log it in a DMV called sys.dm db tuning recommendations. If you have automatic tuning enabled, what it will go ahead and do is use the force plan logic in the query store, which we're going to show in a second, enforce that plan so that you revert back to a well-known good plan. And in order to do this, this will automatically apply the mitigation if you have the automatic tuning database property on. So let's dive in and let me watch me try to screw around with my Mac. Okay, good. I still have the mirroring screen on mine. Hang on. Okay, cool. Sorry about this. Hang on. Okay, there we go. So that looks a little bit better. Let me make this a little bit bigger. So in this demo, I have SQL Server 2019. I'm using the Wide World Importers database. I have a stored procedure called initialize that's going to clear my plan cache and drop everything. I've also created a couple of stored procedures that I'll walk through. You'll also note here I have set statistics time and I/O on so we can track the runtime of our query. And I have include actual execution plan highlighted so we can look at the actual execution plan. So we'll go ahead and execute this code. And that doesn't really take any time, and it's not what we really care about. But here I'm going to run this stored procedure called DBO report. I'm passing in a parameter. So this is where we're going to get parameter sniffing behavior. And my parameter here has an ID of 7. So this is my package type ID. I'm going to execute this 50 times. And what we're going to do is just kind of watch the results come in for the query. We'll look at the execution plan and the metadata after, but I just kind of pay attention to the results grid and how fast things appear. So we see it's executing pretty quickly. We're executing this 30 times. It should take roughly about 15 or 20 seconds. (13) 15 seconds. So relatively quickly. If we look at the execution plan, we see none of those really scary yellow warning signs. This plan looks pretty efficient. Mostly we're doing a clustered index, so we probably could have another index to make this run better, but this demo wouldn't be as cool if we did it that way. So we're scanning, but if we look at across all of our executions, we see the same plan everywhere. So now what I'm going to do is I'm going to go ahead and execute a stored procedure that introduces regression. What this is going to do is clear out the cache, rerun the stored procedure with a different parameter, and so that plan with that parameter value will then be cached, and that's what SQL Server is going to try to use the next time we execute it. So let's go ahead and execute this. And that's executed. So now we're going to run the same query, and we're going to run it 30 times instead of 50 for the sake of brevity. And now we notice it takes a couple of seconds for our results to come back. And if we look in messages, we're going to see, if I scroll down, we're now doing 677,000 logical reads, not what we want to see for a nice query execution. If we look in the execution plan, we get to see everybody's favorite database operator, at least mine because they help pay my mortgage, key lookup. That means for each row in that index seek that we see against the order lines table, we're doing one execution and one key lookup. So we're doing a row by row operation, and as we can see, it's executing nearly 221,000 times. So not really good, and we see it took 15 seconds to execute that 50 times, but now with this new plan, it's taking 23 seconds to execute it just 30 times. Not good, not good. We probably at this point have users calling us complaining that things are slow. I don't have anything enabled, but I can go look in the query store. And if I go to top resource consuming queries, I see, since our query store was pretty empty, we only have one query. I can identify that it's my query. And I see that there are two execution plans. And if you haven't used this view in the query store, that's execution duration in the left. So this is the number of milliseconds. And I believe this is the total that I have configured now. Yeah, it's total. So here if I do average, you can see what the average time was. So the average time was 155 milliseconds. We can see the minimum duration, the maximum duration, the standard deviation. These are all stats that the query store uses to track query performance and make decisions for this automatic tuning process that we're going to show demo in a second. Here we see our average duration was 621 milliseconds. And we can mix this up by doing some configuration. Like if I just want to see logical reads. Here I can see my average logical reads for my better plan was 37,000. And if I go to my not as good plan, We see the average logical reads are, we really need commas in the query store, but 5.4 million in kilobytes. 5.3 million is the max. So let's go ahead and enable that feature and see what happens. So we're going to clear everything so we don't have anything in our query store. And now we're going to enable this. And so we're going to do alter database current, which is the database we're in. And you should note that this is a database level setting, so you need to configure it at the individual database. You can also configure it from the Azure portal if you're using an Azure SQL database. And then now I'm going to verify that this is on by checking this catalog view, which is called sys.database.automatic tuning options. So there we go, we see it. And now we're just going to repeat the same workload. So we're going to run 50 times again, and then we're going to induce the regression. So this is going to be our good plan initially. And we see that returns quickly. We can see that each execution is doing 4,600 logical reads and is taking about 200 milliseconds total. And we're done again in 15 seconds. We see we have our good plan. Now we're going to go back and reinduce regression. So we want to show this regression problem that we had before. That'll run really quickly. And now I want you to pay attention again carefully because we're going to run this and it's going to be slow at first. As you can see, this is moving a little slowly. And probably at about 10 seconds, you'll see this starts to return a little bit faster. You can see that that bar on the right-hand side is moving up really quickly. And we finished our 30 in 16 seconds versus the roughly 30 it was taking before. And if we look here, we still see our bad execution plan. But if we scroll down, query 11, the 11th execution, we still have it. 13, 14. On execution 15, we have suddenly reverted back to the good plan that ran faster. And now if we go back into Query Store, and I do a refresh, I can see a check mark on that plan, which is indicating that SQL Server went ahead and did a forced plan automatically. So now SQL Server, when it gets that query, will always use that plan. Is this perfect for everything? No. But does it work really well for some workloads? Yes, and especially in a report scenario like this where you might have data skew. One of the challenges that I've found with this at customers, we've mostly enabled it places, but it doesn't always work where you have large drifts or it will self-correct. Or if you have queries that don't run that frequently. This works really good for an OLTP query that's running a lot because it takes 15 executions in order to fix it. However, in a lot of like larger data warehousing scenarios where if you have big ETL queries that might get a big plan, maybe they only run 4 times a day, and you don't necessarily get the benefits of automatic tuning. So I would like to see this feature be a little bit smarter. But it can be really helpful, especially in Azure, where you maybe don't have a dedicated DBA or someone if you have a large number of databases and you just want the database engine to handle this for you. We have a few minutes left. Do we have any questions? Why was it 15? The question was, why was it 15? I've asked the same question of the product team, and the kind of answer I've gotten was that was based on analysis from telemetry from Azure SQL database. I think 15's, what I would like it to be is tunable. It's internal, so you can't change the number. I would either like it to be adjustable or a little more logical, right? So like that if performance regressed based on it, because it's based on percentage regression in terms of CPU seconds for query execution. So what I would like to see is, if it's like 25%, sure, 15 times is fine. But if it's like 1,000%, just go ahead and go back to the last plan. But I assume that's a lot harder to implement, and I don't write C++. So, any other questions? Yeah. The question is, which version of SQL Server is this available in? This is in SQL Server 2017 and 19, and all flavors of Azure. This particular feature does require either Enterprise Edition or Azure. Any other questions? Well, thank you, everyone, and have a good day.